This video goes over what a function actually is. A function is going to allow us to do all sorts of modeling and make predictions in different types of situations. So a function is a relation in which for each value of x, there is one unique output. So let's take a look at identifying what is a function and what is not. So in my first example here, I've got minus 5, 1, minus 3, 2, minus 1, 3, and 1, 2. This one is a function because none of the x's are the same. So what that means is for every value of an x that is put into the function, you get a unique value of y. Even though you happen to get two y's here, the x's are not the same, which means that you still get a unique output. What we have here in our table of values, I'm going to see that I do have two x's that are the same, giving different output values. So this is not a function. If I was to do a mapping diagram to demonstrate which value of x mapped to a particular value of y, I would notice that I have one x value, 0, going to two different outputs. That is what makes it not a function. In order to determine graphically if a relation is a function, we can use the vertical line test. If any line passes through 2 points on the graph of a relation, then the relation is not a function. And this is a vertical line that we're using. So let's take a look at some applications. Here, I'll get out my ruler so I can draw some nice vertical lines. If I use my ruler to draw a vertical line here, this is not a function because it does not pass the vertical line test. My vertical line goes through 2 points on the relation. Let's do this one over here. Now I'm going to draw a vertical line, and what I'm going to notice is that it only crosses my relation at 1 point. So we would say this is a function because it passes the vertical line test. Now on my scatter plot here, what I want to notice is that I could draw a line through this point and it would only touch once. Same with this point, same with this point, same with this point, but all of a sudden I'm going to get to this situation where when I draw a vertical line, I go through 3 points. So that means that it's not a function because it does not pass the vertical line test. So, to summarize, how can you check if a relation is a function? So from a graph, we can use the vertical line test. From a set of ordered pairs, we can ask ourselves, are the x values the same? And same thing with a table of values. Are the x values the same? From an equation, we've got two options. One would be to sub a y value in and see if you get two answers for x. And option 2 would be to graph it and use the vertical line test. Okay, so let's move on to our second topic of this note, which is our domain and range. And so our domain is just going to be the set of all x values in the relation. And the range is going to be the set of all y values. So just sort of like you're describing boundaries for tag or hide and seek. You're just describing where the function can go in the x coordinates and where the function can go in the y coordinates. So what we want to be able to do is to state the domain and range for a given function. So in example 3 here, my first one, my domain is just going to be the list of my x coordinates, unique ones. My range is just going to be the list of my unique y coordinates. So I don't need to list 2 twice, I only need to list it once. If we move on to B, now I've got a function. And what I want to do, rather than listing all my points, is I want to represent all the values of x just as a range. So what I'm going to do is use interval notation, and I'm going to notice that I can substitute in any possible value for x. My range, however, has to be greater than 0, and I can represent this like this. The square bracket means includes, the open bracket means does not include. In example C, we're looking for the domain and the range. So the domain is going to be all our x values. So right from -5 all the way over to +5. And we include both of our endpoints. And then our range is all of our y values. So from -3 to +3. Example D, we've got a scatter plot. So kind of like our first example where we had the list of ordered pairs, we are just going to list all our possible x values here. -1, 0, 1, 2. And then we're going to do the same thing for our range. List all of our possible y values. And remember, we only need to list each y value once. So even though 2, for example, here occurs 3 times, we only need to list that once. Same thing for our x value of 1 here. We only need to list that once. Our last example here that we're going to state the domain and range for is half of a sideways parabola. So our domain is all of our x values. Our function is going to start at 0 and it goes all the way over to infinity. And our range is going to be our y values. So we're going to start at 0 and go all the way to infinity in the y direction. Our last piece of information that we need here to be able to discuss functions is function notation. So an equation that is a function can also be named using a different notation. The symbol f at x is another name for y, and it represents the value of f, our function, at x, a given value of x. So if we're given the function here, y equals 3x plus 2, the first thing we're asked to do in function notation, all we're going to do is replace y with f at x. The right-hand side stays the same. We're just going to replace y with f at x. The next thing that we're going to do is calculate f at 2. So what that says is that x is going to equal 2. So I'm going to put in a 2 wherever I see an x. In this case, there is only one spot. I can evaluate that, and I'm going to get 8. So that tells me that f at 2 equals 8. The ordered pair that I would plot on a graph would be 2, 8, x, and then y. I'm going to do the same thing down here for -3. We'll do that in green. So wherever I see an x, I'm going to put in -3. Evaluating that is going to give me -7. If I were to plot this on a grid or interpret it graphically, my x value would be -3, my y value would be -7. We can also find the value of x in a particular function value. So we're asked to find f at x equals 20. This is like saying y equals 20. Find x. So now I'm solving a two-step equation. I'm going to isolate x using opposite operations and find that x equals 6. If I were to interpret this graphically, the point on the graph would be 6, 20.